energy saving ceiling lamp, 18 watts. Very small. Okay. Let us open the plastic. Plastic. What is this? Metal? Then we have the wire for 220. The screw for this it only measure one hand. Okay. Oh, this is just for the ceiling attachment for the ceiling, and then it's clip. Now we have the circuit made up of capacitor, inductor, and some IC, one IC. And we have this button type LED. This is used for backlighting, LED backlighting. Also with the resistor IC, 2 capacitor, and then inductor. And we have this wire from the 220 volts with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 LED, making it 18 watts for this lamp. So after a reverse engineering of the LED, this is the actual wirings now of the ceiling lamp, equivalent to the actual wirings. The LED is connected in series with 2 capacitor, 2 resistor, inductor, then the IC connected to 220 volts, this one, 2 capacitor, LED connected in series. Now we have the diagram of the LED driver. Okay. And then these two, they are the same. This is the actual wirings, and this one is the LED driver KP10790WP schematic diagram with pin out 1 to 7. 1 to 7. So here the pin number 1 and pin number 7, they are connected to 220. Okay, pin number 2, that is the ground. Pin number 3 of this IC, the KP10790WP, is supposedly a resistor overprotection voltage, overprotection. This is for overprotection, connected to pin number 3, then to the ground. That is R2, equivalent to approximately 200K. In actual circuit, it is connected to pin number 6 and then to the negative side of the LED. So in actual, it is connected here. Also, it functions as overload protection. So instead of placing the resistor to pin number 3, it is now located into the output, positive LED to the negative. So it also functions as a overprotection, for overprotection, overload. Okay, and then pin number 4 is the current sense resistor. Because of this resistor, it dictates what current is supposedly into the output. What current is now in the output. And then pin number 5 is the drain. So drain is in MOSFET. There is a drain. So if this is the MOSFET, this one is the drain. And then to the ground. So current will flow from the supply, then to the MOSFET, then to the ground. So here, just like this one, pin number 6 is the high voltage, connected to the capacitor stabilizer. At the same time, as a filter, there is an LC filter to the output. All LED is connected in series, and now causing this all components, the current into this component to flow into the pin number 5 to the drain, because drain source of the MOSFET. Okay, in order to turn on this LED, and we have this capacitor stabilizer for the circuit. This one is capacitor stabilizer or line filter for the output. So all the current here, and then to the resistor as an overload protection resistor, will go to the coil and then to the pin number 5, which is the drain of a MOSFET. So as we can see here, there is no full bridge rectifier or any rectifier use, but this IC, there is a rectifier inside this IC. So that's why we just use an IC instead of a diode or any other kind of rectifier to convert alternating current. This is AC, and then will become DC here. The output now, what is now the output? DC output, high voltage DC. So making this LED, all in all, we have this 18 watts of power. Kahit pati di kita bahagian. makakakorto dyan. Oo, ano na? Ay, ba't nilagyan mo pa niyan? Hindi talaga, bakit sabag yan? Akin lang yung kita ng YouTube pag may data. Ayun, may ano, may tambol. Ah, ito lang.